Hello interwebs, welcome to Let's Fix Computers. I've got a MacBook Air here. This is an A1465. So this came in with a couple of symptoms. The customer had a knackered charger, and they also said that the battery wasn't charging. And so I plugged the laptop into one of my known good chargers, and two things happened. Firstly, I could see there was an issue with it charging even on a known good charger. So I was like, cool, okay, it looks like you need a new battery. However, I immediately smelt the unmistakable smell of burning electronics. Anyone who has smelt that before knows exactly what I'm talking about. And when you're in a shop like mine and you get that smell in your nose, everything stops. You need to find out what is burning and stop it from burning, you know. So yeah, immediately I was like, okay, wait, there's something else going on here. So we looked in, so I took the back panel off of this thing to find out what was going on. I was like, it's not the charger, it can't be the battery, because batteries don't make smells like that. Well, I haven't smelt it anyway. And then I spotted this. Whoop. What the hell happened there? So yeah, that's our guy that's making the smell. So it turned out this laptop actually has three problems. The customer has a knackered charger because the end was all frayed and it was all busted up. The battery is probably busted, and we have an exploded cap, which, unless I'm mistaken, is part of the input capacitance for CPU vCore. So yeah, we really don't want this guy sitting on the input rail to the CPU. So we've got the main job that I need to do is I need to take this motherboard out, this logic board out today. We've got to get that guy off, and we need to find out what his job is, and I'm probably going to replace this one. I'll tell you a bit more about that in a moment. So first of all, let's get the logic board out, and because this is an Apple, I have full schematics for this. So we can actually look this up and look at exactly what it does and, you know, what it would be replaced with. So this board is an 820-3435B, as you can see there. This guy, as we can see from just the general board layout, you've got your CPU here, and we've got pairs of inductors and MOSFETs right next door. So this is going to be CPU vCore, the power supply for the CPU. And then if we follow the traces for these, you can see this black trace here that's going to all the positive pins of these capacitors. That's going straight into these MOSFETs here. So this is input capacitance for this power supply. And the purpose of that is that CPUs like this, modern CPUs in general, they can bang onto load very quickly. They can go from using almost no power to using a crap ton of power in milliseconds or even less. You know, the speed that they switch from a low power state to a high power state is incredibly fast. And when this guy bangs on load, it suddenly starts gulping power out of the power supply. And the power supply has to wake up and react to that. And not only does the power supply have to react to that, but it actually needs a reservoir of power to be able to grab so the CPU can pull it all out. And that is going to come in the form of this capacitor bank here. So electricity, when you're working in the order of nanoseconds, as these boards are doing so, electricity moves slowly through the board because it's actually like an elastic band. If you pull on that elastic band really hard, the elastic band isn't going to follow you. It's going to stretch and then follow. So what you need is these bank of capacitors that have a whole pool of electricity stored in them. So when CPU vCore suddenly tugs on the power line, there's a whole load of stored energy there ready to go straight in while it waits for all of the power going through the rest of the board to catch up. So that's what this capacitor bank is doing. There will also be output capacitance as well. So there will be more capacitors on the output from the inductors and the input to the CPU. So this board isn't a terribly good example of that. There's not a lot going on the back here. It looks like they're mostly relying on input. However, if I switch to, here's a donor board I've got on hand here. This is an older one. So you can see we've got, let me see, I think that one, no, that's our GPU. That's going to be our CPU. If we look on the back of that, as you can see, we've got capacitors dotted on the back. Not many, and we've got a bunch of big ones there and a whole ton of small ones. So you can see that is the output capacitance or bulk decoupling or bulk bypassing for this CPU. So when this CPU suddenly bangs onto load, there is literally a bank of small, tiny little batteries on the other side of it to immediately provide that power while we wait for CPU vCore to wake up and start supplying more power. So that is what is going on with this capacitor bank. Let's look this up on the schematics for this board, because I have those on hand. So just a quick thing, I do often get comments asking me for schematics. Go Google for them. I cannot supply them for you. Okay, right, here's our schematics for this board. So, and I've also got the board view for it open. So what we can do now is, again, because we have full schematics, because these are Apple logic boards, which are very well documented, I can just look up all the information we need. So firstly, this is the guy that's gone bang. And if we check on its positive side here, we can see that this is PP-Bus S5 HS Computing iSense. And if we follow this to where it connects to these two high side transistors. And if we check the outputs of these transistors, as you can see, we've got CPU VR phase 2 and CPU VR phase 1. And then there is our phase 1 inductor, there is our phase 2 inductor. So we have a 2-phase buck power supply. I have a video on my bucket list where I'm going to make a video that explains about multi-phase vCore and more detail about how that works. So I'm not going to go into super details here, but I do have a video in the works where I talk more about what dual phase or multi-phase VRMs are actually doing, why you have multi-phases, and how those phases work together and stuff like that. Because there's a lot of interesting information about how that applies to PC motherboards as well. Because a lot of PC motherboards, you see them running 8, 12, even 16 phase CPU vCore supplies. So yeah, it gets really complicated. We'll go into that in another video. In the meantime, so this guy is input capacitance. So this is C7374. So on the schematic, I will search for C7374. And that brings us to, there we go, up in the top right here. So this guy up here. So as you can see on this page, we are on CPU voltage regulator 12.5, power stages and stuff. And looking at this, let me just zoom in slightly. So as you can see, we've got pairs of MOSFETs here. And so we've got the high side MOSFETs, which are on the high voltage rail. And then we've got low voltage MOSFETs, and those pull down to ground. And then between that, we've got the outputs going through the inductors here and here. So that is our 2-phase power supply. So the actual capacitor that's gone bang, what were we searching for again? It was 7374, which is up here, additional input bulk caps, 7374. There's our guy. So this is the dude that has gone bang. It's a 62 microfarad capacitor, and it's 11 volts, and it's a polytantalum capacitor. So tantalum capacitors are notorious for failure. However, they're kind of a necessary evil because tantalum is a cheap way of getting a lot of capacitance into a very small package, which is what it takes to make laptops that are small and thin and light like this. So yeah, it'd be that way sometimes. Okay, so we've got to remove this guy off the board. Now, you guys have seen in previous videos where I've removed capacitors and then not bothered replacing them. The times when I don't bother replacing them is usually when the capacitor is not doing anything particularly important. I also have a video in the works where I'm going to go into more detail on how you know what the capacitor is doing or the other component is doing, and when to know whether you need to replace it or not, and more often than not, how you can go about finding spare parts. However, I'm short on time, so I want to keep this video brief. we are going to replace this because this is an input cap for CPU vCore. Without this, vCore has less input capacitance, and that's a bad thing. In the worst case scenario, what this might mean is that if the CPU hammers on and off load very quickly, because there's not enough bulk capacitance, as soon as the CPU bangs on load, it runs out of power and crashes, and the system will lock up. That is what will happen if there is not enough. Now the chances are, notice this is labeled additional input bulk caps. We've also got, all of this stuff here, all of this stuff here as well. So we're not short on input capacitance here. The chances are that, well, the laptop does work just fine. This laptop starts and runs with this exploded cap, believe it or not. We'll get to that in a moment. So yeah, it isn't actually required, but it will be a very good idea to replace this one because of its role in the laptop. So we're going to replace it. Now, unfortunately, due to time constraints, I haven't been able to source replacement capacitors of this value. However, I have spare boards here. I've got breaker boards. These are dead boards, and they have lots and lots of components on it from other MacBook Airs. And the chances are we'll find a capacitor of equal value that's in good health on one of these boards. I've actually already looked one up to double check, and we have got one. So I'll show you what I found there. So this board that I've got here, this is an 820-2796, so it's a much older board. And it has over here C7041. I looked this up on the schematics for this board, and C7041 also happens to be an 11 volt 63 microfarad capacitor. So we can remove this capacitor, we'll do a quick health check on it just to make sure it works and that it's meeting its specification, and we can stick that on the board instead. In an ideal world, I would actually go and buy brand spanking new ones. However, this board is a rush job. It needs to go out immediately, so we don't have time to order parts. So for now, we're going to stick another one on. However, as I say, I'll be testing this to make sure that it meets specification before I put it on the board. So first things first, we've got to take the old one off the board. So I'll just quickly put a heatproof mat underneath that, and I'm going to turn on my hot air station. And we're going to start warming this guy up. I'm just going to blow from a distance first and just get some rough heat into the general area. I need to be careful not to melt this connector here, otherwise I'll have a bad day. So most likely what has happened to this capacitor is it probably failed, and as most capacitors do, it would have failed short circuit. And then immediately, because it's sitting on a high voltage, high power rail, it then went into meltdown and it just exploded like this. So this is quite a spectacular failure. However, luckily, it's exploded to such an amount that it's gone open circuit. It's blown apart. So there's not actually a short circuit here, which is great because otherwise we could have done more damage. Right, let's go in for the melt. There's a quick gore shot of the capacitor we've just removed. So as you can see, it's literally blown apart and just melted into blobs inside. So yeah, that probably, it wouldn't have made much noise when it went bang, but this is why we could smell burning. Right, that's that guy off. We knocked one of the other capacitors sideways then, but that's fine. We'll correct that when we put the replacement in. Right, next I need to remove my donor cap. So stick this guy and heat this up. This is a donor board, so I'm going to be fairly vicious with it. I'm just going to go straight in and melt this guy out. Right, this is my transistor tester, which is a cheap component tester. You can buy these built or in kit form from all kinds of websites, you know, Amazon, eBay, AliExpress, yada, yada, yada. And it tests components. You can put legged components into this connector block, or you can put SMD components on these pads, and it'll basically tell you what it is and what the specs on it are. So let's start out with the real one that we removed. So I'll put that on there. Now, bearing in mind, this thing is not the most accurate thing in the world. A proper LCR meter will be much more accurate. However, this will give us ballpark figures, which is what we need. So I'm going to press that down, and let's see what we get. All right, so we've got high 80s, nearly 90 microfarad, which is reading over, but as I say, allow for accuracy here. The ESR is 0.06-ish ohms. So yeah, that's looking fine. Now let's try our donor one and see if this guy is any use to us. Pressing down. There we go. We've got 75-ish microfarads. And again, we've got 0.06 ohms ESR. Now, the ESR is probably lower than that, bearing in mind we're not soldered down to these pads, we're just pressing them on, which is a terrible connection. So the ESR is probably even lower than that. But the main thing is that we're down in the 0.0 something or other. Whereas if we were up at 0.1 or 1 ohm or something like that, that means the capacitor is goosed because the ESR is through the roof. So that would mean that even though it might be giving us the right capacitance, if the ESR rating on it is no good, that means it's not going to be able to switch fast enough. So with capacitors, now I'm at the edge of my knowledge with this, but when it comes to ESR, the point of ESR is how fast the capacitor can drain and can charge and discharge. So the equivalent series resistance, so it's basically how much resistance there are in the legs and the package of the capacitor. And if your capacitor has got a huge amount of resistance just in the body and the legs of it, when it's trying to charge up, it's getting bottlenecked by the resistance in those leads, which means it's not going to charge up fast enough for how quickly the device requires it to. So again, this is an enormous generalization, but it gives you a rough idea. So one of the things that is an absolute classic for failed capacitors is they may not have gone short circuit. They may not have gone open circuit. They might even read the correct capacity. However, if the ESR has gone through the roof because the package has just broken down, then that means it's not fit for purpose. However, this guy is within the specs we need, so we'll put it on the board. Right, more flux has been added. I'm going to turn down my airflow now, and we're going to flow both of these at the same time. So we're going to stick one guy there, and we're going to stick this guy back on there. Now we're going to just go in and just heat those guys up. Again, I'm just aiming the air nozzle away from the connector. That'll do. Good. Right, that's actually gone on quite tidy. I didn't press down very much on them, so there might be a little bit of excess solder that those are sitting in. However, that is good enough. I'm going to quit while I'm ahead. Yeah, if we go for the side view on that, you can see those guys are flat on the board, so that's hunky-dory with me. So I'll check for short circuits now. So one probe on ground, and in continuity mode we should have ground on this side, but not on this side. Lovely. Good. Groovy. Right, that is our capacitor replaced. So now we can put this thing back together again, and I can power it up and I can start addressing the battery issue. So I'm not going to go over the battery issue on this because it's kind of boring, really. The laptop needs a new battery. Buy another one. Buy it on Amazon. Buy it from the supplier of your choice. Yeah, replace the battery, replace the charger, and this thing will be done. So we'll get it reassembled and we'll make sure it works. Right, camera end at the back in case it goes bang. Power on. It may power cycle a couple of times. MacBook Airs do that. Yeah, there's the first power cycle. There's the second. And I think this time it'll chime. Nope, no chime. However, it's turning on. There we go. As you can see, it starts and runs. And now what I'll need to do is, just because the laptop turns on and boots up, that doesn't mean we're out of the woods, because as I mentioned, that capacitor, that's bulk decoupling. So we actually need to stress test this to really know if it's working properly. So what I'm going to do, just as a poor man's test, I'm going to set this up with just Handbrake running on it, which is a video encoder. And what I'll do is I will set up a video encode and then I'll repeatedly pause and continue the encode. So that means the CPU will constantly be alternating between idle and 100%. And hopefully that should replicate a slight hammering on the CPU so we can make sure that that is actually hitting load and unload properly. Heck, this thing is on macOS 10.9, so I kind of need to start doing the software service on this before I can do any useful testing. I've got this thing updated to Mojave, so now we can run Handbrake on it. So I've got the activity monitor over here on the right, and as you can see, the CPU is just doing background stuff. So that's just doing stuff. It's not flatlining, but it's really hard to flatline a Mac anyway. In addition to that, I've got activity monitor on update every second, which means it eats CPU cycles anyway. So yeah, however, as you can see, we're using it not a lot. So we'll resume this encode now, and we should see that bang on to 100% load. There we go. So that's cranking up, and Handbrake is now maxing out everything it's got. So the update speed is stuttering a bit here because we're maxing the device. But as you can see, we're fully responsive down here, encoding at a whopping 18 frames a second on average. So yeah, that's running. So let's pause it again. And we should see that drop off. There we go, there's the drop. And now let's hit it again. Resume. So activity monitor is really slow to update, but you can see that we haven't crashed just by monitoring the numbers down here. Because initially it looked like activity monitor was really stuttering, but Handbrake is responding just fine, so no concerns. Yeah, so maxing out, it's all good. Pause, stop, start, stop, start. So I'm literally just abusing it just by stopping and starting the encode here. So I'm just constantly just battering the CPU. There we go. That's fine. We're all good. Right, that's enough for me. So thank you very much for watching, everyone, and I'll see you all next time. Bye for now.